Okay. So today we're talking P3. It's going to be in your note. Again, just as we said yesterday. Sometimes we have note sheets like on Tuesday. Most of the days we don't. We just have taken the notes. Okay. So today we're talking equations, solving an equation, solving linear equations in one variable, and solving linear inequalities. We'll get to all of that. Why was the equal sign so humble? They weren't, he or she, for that matter, knew that they weren't greater than or less than anybody else. Humility. All right. So, good warm up here. I want you to write me a linear equation in standard form. So this is going back to Tuesday now. I want you to write me a linear equation in standard form that goes through those poles. 7, -2 and 5, -1. I'll give you 3 minutes to do it. Go. Now I can go because it just said go. Okay, what's the first thing that I gotta do? What's the first thing I gotta find? I gotta find the slope between those 2 points. Yes, indeedly do. So that's gonna be y's over x's. -2 minus -1 is like -2 plus 1, so that's going to be -1. 7 minus 5 is 2, so that is my slope. Love it. Do we all have a slope of -1/2? Okay, that's a good thing. Second thing that I got to do. Got my slope. I got 2 points. What should I probably use? Got the slope. Got 2 points. Should probably use point slope form. Okay? Point slope form, remember, is y minus y sub 1 equals m times the quantity x minus x sub 1. Right? Which point do you want to use, left or right? Follow-up question to left or right, does it matter? No, it doesn't matter at all. So what do we want to use, left or right? Pick one. Left. We got left up here. So that's going to become then y minus -2 equals -1/2 times the quantity x minus 7. Yes? Okay? Now, it said, though, we need it in standard form. What are the 2 kickers from Tuesday with standard form? Kicker number 1 is x and y are on the same side. Do I have that right now? No, I don't. So I'm going to have to do some stuff. What's kicker number 2? No fractions. Yep. Do I have fractions? Yeah. Which one do you want to do first? Do you want to get rid of the fractions, or do you want to move the stuff? Let's get rid of the fractions first. So how can I get rid of the fractions in this equation? Multiply both sides by 2. Love it. So if I multiply both sides by 2, then I've got 2y plus 4 equals -1 times the quantity x minus 7. Which I can distribute that -1 then, right? So that's going to be 2y plus 4 equals -x plus 7. Okay? Do I have any fractions? Any fractions anymore? Nope, that's a good thing. So that condition's done. Now I just got to go back to my other one and I got to get x and y on the same side. So I'm going to add x, and at the same time, I'm going to subtract 4. Because I can do that. We're smart like that. So I get x plus 2y equaling 3. Standard form always goes x then 1. Good? And that, ladies and gentlemen, is my answer. That is the equation of the line in standard form through those 2 points. Questions, comments, concerns, clarifications? Moving right along. Why do we do this stuff? Well, these topics are the foundation that we need in order to get to that. And I'm pointing to the unit circle up on the wall. Okay? So we need the algebra to get to that, so we can use that to get to launching a steel ball from like right here through a ring, like right here, and landing it in the cap of a soda bottle. Okay? Which you'll do in March. Okay? You'll do all of that in March. We're going to put a table right there. We're going to launch a steel ball. We're going to go through a ring. The ring is right up on top of there. We're going to land it in a bottle. Okay? So we need that. So we got the skills to pay the bills. All right. So an equation is a statement of equality, okay, between 2 expressions. Remember, an expression is just a grouping of numbers and variables and things of that nature. Okay? So we've got equations. So there are some properties that you need to know in regards to equality. So the first property that you need to know is the reflexive property. Okay? Anything is always equal to itself. You are equal to you. You and I are not equal because we're not the same. 7 is always equal to 7. Negative 93 is equal to negative 93. Reflexive property. You know that. Symmetric property. If u equals v, then v equals u. Okay? What this property is telling you is that when we're going to get into solving equations here in about 2 minutes. Okay? So if I solve for x on the left side, and you solve for x on the right side, we'll get the same answer. Okay? Doesn't matter which side of the equation you solve. The symmetric property tells me they both be the same. Transitive property, if u equals v and v equals w, then u equals w. Okay? Because you're just taking out this bridge between the v and the v. You're just bridging that gap. Oh, yeah, neat. I've changed that. Here, let's pause. Here. The addition property says that if you add something to the left side, you got to add the same thing to the right side in order for it to remain in equality. Again, this is all stuff that we called this. You learned this back in Algebra 1 as the golden rule of algebra. What what you do to one side, you got to do to the other. Because you could have the addition property. It could be the subtraction property. It could be the multiplication property. It could be the division property. It could be the root property. You take the square root of one side, you got to take the square root of the other side. It could be the power property. If you square one side, you got to square the other side. Okay? It's the golden rule algebra right there. See, and then there's the multiplication property. Okay? And this is just, we kind of combine this with the transitive property too. This one I want to keep W equaling Z, because then if we multiply by the same thing, because there are going to come times when we're going to either multiply by the same thing on both sides, or we're going to add on the same thing on both sides, but they're not going to look the same. Okay? Particularly if you're adding fractions. So like if we're adding 3 to one side, but there's a fraction of fourths on the other side, I'm going to add 12 fourths on the other side, because then our units are the same. It's still adding 3, but it just looks a little different. Here we go. Okay? A solution of an equation in X is a value of X. Anybody know what a solution is? Or the true definition of a solution? It's not what X equals. It is what makes the equation true. And that's what a solution is. A solution makes your equation be true. To solve an equation in X means that you're going to find all the values of X that make that equation true. That is, to find all of the solutions, because a solution makes the equation true. Okay? So when you're solving, you're not just finding one, you're finding all. Okay? Now we're going to. Yes! I love it. All right. You've done algebra before. Let's do this one together. 2 times the quantity, so I'm going to read this how it should be read. 2 times the quantity, 2x minus 3, plus 3 times the quantity, x plus 1, equals 5x plus 2. Somebody, I don't care who, somebody tell me, what do I do first? Where? So I distribute the 2 into the 2x minus 3. Can I do anything else at the same time? Distribute the 3 into the x plus 1. Now you'll find that I color code all of my stuff. Okay? So 2 times the quantity 2x minus 3 is 4x minus 6, correct? 3 times the quantity x plus 1 is 3x plus 3. Now what? Yes, ma'am. Okay, what do you got? 7x minus 3, do we all agree? I would agree that we got 7x minus 3 over here. Now, there comes a time. Was it Emerson? 2 paths diverged in the woods? Is it Emerson? Is it Ralph Waldo? I think it was Ralph Waldo. I'll look it up. 2 paths diverged in the woods. Really, but not one less traveled or one other traveled. We just got to make a decision. Okay? We've come to a fork in the road. That was Kermit the Frog. He came to the fork in the road. And which way do we go? Do we have variables on the left side, numbers on the right side? Or do we put variables on the right side and numbers on the left side? Or does it matter? It doesn't matter. It doesn't matter. Me in this one, I'd go variables to the left because then my variable still stays positive. Would be me. But I'm a different breed of cat, as Courtney knows. Okay? Next. So I'm going to subtract 5x from both sides. I'm also, at the same time, because I have a brain in my head, I'm going to add 3. Okay. Left side becomes 2x. Right side becomes 5. Still not done? Divide both sides by 2. And that gives me x is equal to 5 halves. Now, we are a fraction kind of a class, because once we get to that, it's all about fractions. Okay? So we are also improper fractions, 5 halves. Much better than 2 and 1 half. Mixed up numbers get my brain all mixed up. Okay? Improper fractions are nice, but pretty neat. Okay? Quick check. 5 halves times 2 is 5, minus 3 is 2, times 2 is 4. So this one over here is 4. 5 halves plus 1 is 7 halves. 7 halves times 3 is 21 halves. So that's going to give me 829 halves on the left side. 5 halves times 5 is 25 halves, plus 2. 2 halves is 4 halves, so that's going to be 29 halves. Boom. Did it, done, did it, write it. Nailed it. Okay? Go for it. Solve me for what? Out of curiosity, what did some people do first? Tell me what your first step was. To fourths? Okay, right? Converted the 2 to fourths, so then you got 8 fourths, and then you combined those two on the side, so you got 8 plus y all over 4. Then what did you do? Multiply by 8 on both sides. Could have cross-multiplied there too. Yep, love it. Started by multiplying by 8 on both sides. Anybody else? Anybody do anything different? Are either of those methods wrong? No. Will they get us to the same spot? Yeah. There's many different ways that you could go about this problem. Okay? It's kind of like, I always say, to get from Wassa West to Mozambique. Okay? I could jump on the highway and go right there. Right? I could also go out to Marathon and then down 107 and back in on 153. Okay? That works. I could go down to Rib Mountain and I could go past the school forest on KK. Right? All of those roads get me to Mozambique. No one is better than the other. Okay? Maybe you want a slow country drive, go out to Marathon. Maybe you want to get there, jump on the highway. Okay, doesn't matter. It's all personal preference. So me, I'm going to multiply everything by 8 first. I did like to get everything in fourths on that side too. Okay, so if I multiply this one by 8, or the left side, that's going to give me 5y minus 2. If I multiply by 8 on the other side, that's going to give me 16 plus 2y. Now, if I subtract 2y, and if I add 2, I get 3y equals 18. And then when I divide by 3, I get y is equal to 6. $30 minus 2 is 28. 28 eighths on that side. 2 plus 6 fourths. So that's in fourths already, so I could just divide this by 2 and I get 14 fourths. This becomes 8 fourths, and that gets me 14 fourths. Love it. Erase that one. All right, here we go. So, linear inequalities now. All of your rules are the same, except you got this one over here. You got this, if I multiply or divide by a negative, you've got to flip the sign. Okay? When you multiply or divide by a negative, don't forget to flip the sign. Okay? But otherwise, everything else stays the same. I'm still going to distribute. Still going to combine like terms. Going to subtract 5x because I want to do that negative thing. Going to add 1. But now here, when I divide by negative 2, I am dividing by negative 2 right there. So this inequality needs to flip. Okay? It went from less than to greater than. Okay? Now, what we learned yesterday was that that's the inequality for it. We could also write this as an interval. We can also write this as a graph. Okay? You try that one. First off, what do we do? Multiply by 3. Where did we multiply by 3? Everywhere. So I got to multiply by 3 here, here, and there. Okay? So then that's going to give me negative 9 is less than 2x plus 5 is less than or equal to 15. Now what? Subtract 5 where? Everywhere, yep, all 3 parts. So now I'm going to subtract 5 here, there, and everywhere. So that's going to give me, then, negative 14 is less than 2x is less than or equal to 10. Now what? Divide by 2 everywhere. Question of the day is, do I need to flip my signs? Why not? Not dividing by a negative. Regular division and multiplication are fine. It's only multiplying or dividing by a negative. Okay? So then that gives me negative 7 is less than x is less than or equal to 5. That would be my inequality, correct? We could also write that as an interval. We could also write that as a graph. Agree? Love it. Okay? So there are some suggested problems for your book. Basically, the suggested problems are look through in the P3 section on Canvas and see if you know how to do all the problems in every section. If you don't, focus in on those selected problems. Okay? But you should know at this point in time how to do them.